Hello. Today we're going to derive the Schrodinger equation in a simple way. We're going to start by reminding ourselves that total energy is kinetic energy plus potential energy. And we usually write that as total energy is half mv squared plus u, where u is the potential energy depending on where we happen to be, whether it's a gravitational field, an electric field, or whatever. We can also write half mv squared as p squared over 2m plus u, because you may recall that p is mv, and therefore p squared is m squared v squared, and if you divide that by 2m, you get half mv squared. Okay, we're also going to use a wave, and our wave is going to take the form of psi is e to the I kx minus omega t. And you'll need to see another one of my lectures to establish why we use that particular form for a wave. Now, let us differentiate that wave with respect to x, holding time constant. If we do that, differentiating an e function, or an exponential function, is very simple. You take the two terms, the I and the k, which are in front of the x, and you bring it down in front of the exponential term. And it simply becomes ik times e to the I kx minus omega t, which of course is one and the same thing as saying ik times the original value of psi. Okay, we'll keep that. And now we're going to differentiate again. So we're going to take d2 psi with respect to dx squared. And that means you bring down ik again. So now you're going to get ik squared times psi. Now let's just remember that k is equal to p over h bar, because I'm defining k as 2 pi over lambda. And if we work it through, we know from the formula that p equals h over lambda. Therefore, p equals h over lambda is 2 pi over k. H over 2 pi is just the other version of Planck's constant, and we've got p equals h bar k, so k is p over h bar, which we can use. So now we can say that d2 psi by dx squared is ik squared is of course minus k squared, and minus k squared is minus p squared over h bar squared times psi. Multiplying through by minus, we get minus h bar squared d2 psi by dx squared equals p squared psi. But you will recall that E equals p squared over 2m plus u. And so, if we had the formula we had before, we can say E psi. So we can say that E psi is p squared psi over 2m plus u psi, multiplying through by psi. But p squared psi is minus h bar squared d2 psi by dx squared, and we've got a 2m there, plus u psi. And that is the time-independent Schrodinger equation. Simple as that. Now we can go further and we can do the time-dependent Schrodinger equation by reminding ourselves that E is also h bar omega, which is one and the same as hf, where h is Planck's constant. Now if we take our famous equation for the wave, e to the I kx minus omega t, and this time we differentiate it with respect to t, we bring the I omega, it's actually a minus I omega psi. But E equals h bar omega. What do we have to do to convert this to that form? Well, we have to say E psi equals h bar omega psi. Now let's divide by h bar and multiply by minus I. So we get minus I over h bar E psi equals minus I omega psi. But that equals d psi by dt. And so we can say that E psi equals h bar over minus I d psi by dt. And that's simply IH bar d psi by dt. So we can substitute E psi for IH bar d psi by dt into the Schrodinger equation, which you'll remember was E psi equals minus h bar squared over 2m d2 psi by dx squared plus u psi. If we substitute what we just found, that E psi is the same as IH bar d psi by dt, that equals minus h bar squared over 2m d2 psi by dx squared plus u psi. And that is the time-dependent Schrodinger equation. And that's all there is to it.